Hello, students. Welcome back to my channel. In today's session, we will be discussing a searching algorithm. So, we have already completed all the sorting algorithm till the previous session, and today onwards, we will be doing the sessions related to search algorithms. So, the very basic and very first algorithm, what we will be discussing is linear search. So, linear search, as this diagram represents, it is nothing but we are going and searching for the element in a linear fashion. For example, if I'm looking for 6, I'm going to go through the starting from the very first element. I will be going one after the other until I find my element. So that is a basic gist of how does a linear search work. So let us go ahead and see in detail. So before that, what are search algorithm? Why do we require search algorithm in computer science? So, search algorithms are systematic methods used to locate a specific item or value within a data set. So, this collection can be an array, a list, a database, or any other data structure. So, in data structure subject, you would have learned many type of a data structure. Data structure is nothing but the way a data is arranged. So, whenever we are arranging the data in a particular structure, and of course, if we are storing the data, we have to find it and use it in some way or the other. So whenever we are looking for the data, that is where all these search algorithms comes in handy. Okay. So the goal is to efficiently locate the target element or determine if it's not present by comparing it against the element in the collection. So they are fundamental to many computing tasks, from finding contact in your phone to retrieving data from large servers. So that is a very basic example. For example, if you're using a search option in your contact list or probably in a message if you're searching for a particular word. So in all these cases, we are using search algorithms. Okay, so each algorithm has its own approach to this task. This affects its speed and resource usage. Now, whenever we are looking for a particular element, there can be different ways in which we are looking. So, that is what we will be learning in today's session and coming session. So, in today's session, we will be learning a very basic one, which is linear. If I have to search for an element in a linear fashion, how am I going to go ahead and do that? Okay, so let us see the step by step process. First, start at first element. So, whatever the searching element is, so there are two things you need to remember. I will have a search element, okay, which value I'm looking for, and also the data set. So, I am looking for the search element in the data set. So, I will start with the first element, then compare and advance that. As in, for example, if I'm taking an array, I will start with the first element, I will compare. If it is not matching, then I will move to the next value. Similarly, I will move on until I find the match. Repeat until the match is found. And once we find the element, return the index. Index as a position of that particular element. And if at all that element is not present in the data set, then we have to handle it. As in, either you have to display a message saying the element is not found, or in any other way, how do you want to handle that particular situation? So that is how the flow of the algorithm goes. Okay. So this is an example. So this particular picture I've taken from Geeks website. So as you can see, this is the data set, given data set where I have 10, 50, 30, 70, 80, 60, 20, 90, and 40. And the key element or the search element is 30. So I will start from the very first element. I'm comparing 30 and 10 and it is not equal. So next what I need to do, I need to move to the next value. So I move to 50 and I'm comparing whether 30 and 50 are equal. They are not, which means once again, I will advance the index and go to the next position. And as you can see here, 30 and 30 is matching, hence it is equal. Now I can return exit from this particular algorithm and I can return the position saying it is found in the second position, or you can also display it saying it is found in the third position. Okay, so that is how this algorithm works. Let us see the algorithm for linear search now. So the linear search algorithm is a very simple algorithm. You can write it in your own way. In many ways, this can be written. If you have to do it in a very simple way, here we have an example. Let me take this as 10, 20, 30, and 40. I is an index which will be initially 0, and n is nothing but a search element. Let me take it as 40. Now there is a loop which is going to loop Okay, I have to use a loop which will start from the initial value 0 to up till, suppose number of element is x, it will go up till x minus 1. Okay, now every time what I'm going to do is I'm going to compare. A is the name of the array. I'm going to compare if array of I, that is initially zeroth element, is it equal to the value 40. If it is not, then what I'm going to do is increment the counter, as in move I value to the next element. Now once again compare A of, uh, in this case, index will be 1, which is nothing but 20. I'm going to compare if 20 is equal to 40. If it is not, once again move to the next position, that is 30, compare with 40. And initially the flag value, I will take it as 1 initially. So whenever the flag value is 1, which means the element is not found. So the moment we find the element, that is whenever the value becomes equal to n, I will update the flag value to 0. All right. So what is going to happen is I'm going to compare. Every time I move to the next position, I will compare if it is equal. The moment if it is equal, I will change the flag value to 0. If it is not equal, then I'll simply increment the value of I. This will continue. And then finally, I'm going to check that whenever the flag value is 0, that time I'm going to display the number is present at the location I plus 1. Now, why am I saying I plus 1 is because our index is starting from 1, 2, 3, as you can see. And 40 is actually present in the fourth position of the array. But my index will be saying it as 3. So that is the reason I will add 1 and display. So flag will be 0 only when the element is found. This is the else case. Else, if flag is equals to 1, which means the element is not found, then I will display that the number is not present in the array. So as simple as that, you'll simply take a for loop. You'll start, for example, let me say for I is equal to 0 to x minus 1. And then I'm going to iterate through each of the value. And then I'm going to compare. And the moment I find the element, I will update the flag to 0. And the moment I don't find the flag, of course, it will remain 1. At the end, I will check if the flag is 0. I'm going to display the location. And if it is not, if it is equal to 1, then I will say that element is not found. I hope it is clear. So if at all we are talking about the performance, the best case is always order of 1. What do you mean by order of 1 is the target element, the element we are looking for is found at the very beginning. So whenever we find it in the very beginning, it is considered to be a best case because we will terminate from the algorithm. Average cases when we find it in the middle. If there are n number of element and the element is found in the middle position, then we will call it as an average case. But if the element is either found at the last or if element is not found, even whenever element is not found, what is going to happen is, of course, we will iterate through all the element. Only once we reach the last element, we will know that the element is not found. So that condition is called as a worst case. So that is nothing but order of n. So that is the performance time complexity of a linear search. So what is the advantages of linear search? It is simple, it is easy to understand and implement, making it ideal for beginners. No pre-sorting is required. So you need not sort and search the element. Okay, there is no requirement of sorted because there are certain searching algorithm which require your array to be sorted. And sorting is we have to do one set of work, so it will be expensive. Okay, so here sorting is not required and it is also memory efficient because we do not need additional memory space in order to execute that. So those are the advantages. Coming to the disadvantages, it is inefficient for large data. So imagine we have hundreds and millions of data. In that case, if the element is found, if the data what we're looking for is at the end or not found, in order to conclude that element is not found, we have to go through all the values. So that is a problem. And redundant comparisons compares against every element, even when the data might be structured more efficiently. So that is another problem. Scalability issues, performance doesn't scale well with the increase of the data size. Obviously, reasons because it is inefficient for the large data. Okay, so those are the advantages and disadvantages. And if you're talking about the practical applications, despite its limitations, linear search remains useful in several specific scenarios. Small data sets, it is very efficient. Unsorted data, as we discussed already, it doesn't require your data to be sorted whenever you have to apply a linear search. And simple lookups. In situations where an item might be found quickly, such as checking for an item's existence rather than its position, also, linear search is very helpful. So, this is about linear search, students. So, that's all in today's sessions. Thank you for watching.